Okay, homework is the yellow. Let me mention something before we get going. I apologize if I paused, so no one talk. Make sure your phones are put away. I apologize if I caused anyone any undue stress. I use Canvas to keep track of whether you were in class and whether or not you officially completed the homework. So I pay extra credit for getting the homework done, and I obviously try to notice that you're in class, but I also give you points for being in class, okay? So what you need to be doing, and there's not really a strict deadline on this, just keep up with this, you don't fall behind. You need to be going to Canvas, and they're simple checkoff items. You click on the item, it'll just ask the question, were you in class? And you're like, yep, I was in class. If you weren't in class, there's videos that says you need to watch the videos to make up for not being in class. So just make sure you watch those and you check that off as well. When you have the homework completed, same thing. It just says, did you fully complete the homework? You have no questions, you used good notation. You can honestly answer that yes, you click on that. Questions about Canvas? Yeah, if you don't do that, your grade will show an F because it'll just keep plugging in zeros for all those items. Okay, cool. Number 4 on the yellow. Yellow is the homework. The instructions for the yellow are the same as they were for the pink. You're supposed to find the limit as specified, but you're also supposed to examine whether or not there is horizontal asymptote. What's new on the yellow is you're dealing with 2 new types of functions, exponential functions and logarithmic functions. And here are, here are the facts regarding logarithm, or the exponential functions. Okay, E, look, you learned this previously, but just reviewing, and you've got to memorize this. E is just a number. It's approximately 2.7. It is irrational, meaning it is a non-repeating decimal, but for our class, 2.7, close enough. If you have any positive base, like 2.7, 3, 8, any positive base, and you raise that base to an exponent, and the exponent gets more and more positive, the entire expression is going to grow very rapidly. Like it's kind of shocking how fast the number grows. Here's an example. Oh, and the opposite is true. If what you're raising the base to is a negative number that gets very, very negative, it becomes very, very close to 0 amazingly quickly. For example, I made a little spreadsheet to illustrate the idea. So the spreadsheet shows if you take just e to a number and you let that number get bigger and bigger, well, e to the 100 is a number that is 43 digits in length. That's what this is saying. That's a big number. Like we don't have numbers that we deal with in anything I've ever dealt with that are 43 digits long. We just don't deal with things that big. But anyway, e to a positive number grows very rapidly. E to a negative number shrinks very rapidly. This is a number, so e to the negative 100 is basically 0.00044 times, and then some numbers. It's that close to 0. You need to memorize that fact. I'll keep reminding you of it, but you have to memorize that. Questions? We talked about power functions. Here's something to compare to. Here's the power function x cubed. So the green one is 2.7 to the x. The orange one is, something cubed. You plug in 100, so 2.7 to the 100 power. Again, a number that's 43 digits long. If you take 100 to the 3rd power, you just get 1,000,000. It doesn't grow nearly as fast. Much, much slower by comparison. Questions? Then for the other function we deal with is natural log. Take natural log of a number. It grows, but it grows so slow. Natural log of 100 is 4.6. So 2.7 to the 100th power is a number 43 digits in length. Natural log of that same 100 is only 4.6. So it grows very slow by comparison. Questions? Okay, we need that information to work on problem number 4. Because problem number 4 is a limit as x approaches infinity, but we have exponential functions that we're dealing with. So we start the problem just like the pink sheet. We say, okay, x is approaching infinity, so I want to compare terms that are adding. And now you have to remember what I just talked about. So we have this term, and it's to the negative x power. So that means you have, let's write it over here. You're taking the 10 doesn't really make much difference. You have the 10 multiplied by e to a negative 1 multiplied by some number that you're going to plug in, but the number you plug in becomes more and more positive. So this is becoming very, very positive. We just learned that e to a very, very negative number is really close to 0. So as x goes to infinity, this gets very close to 0 rapidly. You want me to talk more about that? So if you have very close to 0 plus 6, what are you really close to? 6. So the limit of this, so this problem has a limit of the numerator that's going to equal 6. Using the same logic, the limit of the denominator is going to equal 2. Notice I don't write the word limit anymore because I am actually finding the limit. I don't have to have the word limit. I'm evaluating the limit. The limit is 6 over 2. You can stop there if you want. The back will say 3. Questions? Now we just get together and breathe. There we go. That was exciting. Questions? Okay, cool. We figured out that as x approaches infinity, y is also approaching infinity. Oh, my bad. Y is approaching 3. That was off target. So we have a right hand horizontal asymptote at y equal 3. Questions? Okay, on the pink homework, you probably figured out fairly quickly that it didn't matter for every single problem in the pink whether x was approaching positive infinity or whether x was approaching negative infinity. In both cases, the asymptote was the same. And so you really didn't have to check both ways. If you want to memorize that for a power function, that's okay. If you're dealing with just power functions like in the pink sheet, it is true that the left half and right half horizontal asymptotes are the same. Now that we're dealing with exponentials, that's not true. So we need to go find the other limit. So draw a line on your paper, and we're going to find the limit. You should write down the limit as x approaches negative infinity. N e to the negative x plus 6 divided by 5e to the negative x plus 2. Please raise your hand if you can tell me, as x becomes increasingly negative, which term, the yellow or the green, will dominate? Hands up, screen. It would help if it would change to green. There we go. Hands up, who knows which one dominates? There we go, Jackson.
Yellow.
So in this case, because we have negative times negative is positive, e to a positive number is going to get large rapidly. Very large plus 6 is going to be whatever the very large is. How many knew? 0.2 for Jackson. We want to talk about it. Okay, notationally, watch the difference. Here, I'm finding the limit. I don't need to say limit anymore because I'm just finding the numbers. Over here, I'm still working on the limit itself. So we need to say equals limit as x approaches negative infinity. I just now have a simpler limit problem to contemplate. Questions? Okay, warning over here on the board. This statement is true. This statement is also true. You can't do this. Like, you can't flip this purple thing. I had somebody last period, they wanted to do this. They wanted to write e to the x plus 6 over e to the x plus 5. That is completely illegal. It's not a rule. Like, you can't do that. Questions here on the green? So now we just split it up a little bit. Okay, raise your hand, please. Tell me if you know what the yellow box is equal to. What is the yellow box equal to, Kate?
Is it 1?
How many knew that? 0.2 for Kate. Here's a trick, they'll try to trap you. Raise your hand, please, if you know. Is there any x that will make the yellow box something other than 1? Like, is there any x we could plug in that would cause the yellow box to not equal 1? Okay. Any x that we can plug in that will make the yellow box not equal to 1?
0.
So if you're thinking 0, give yourself 2 points. Any other answers anyone can think of? Okay, so 0 actually doesn't quite work. Here's why. E to the 0 is 1 itself. E to the 0 on the bottom would still be 1. 1 on 1 is still 1. So that doesn't do anything. Please.
Would it be some sort of fraction?
2 more points. It's hard to explain exactly what e to a fraction is, but that doesn't work either. In fact, you can memorize for our class that this will always be 1. There are no values you can plug in for x that will make this thing anything but 1. It's because e to any exponent, actually any positive number to an exponent is always it's always positive. It's never negative, it's never 0. So any base that's positive to an exponent, you can make the exponent anything you want, positive or negative. This will never be anything but positive. We'll use that in the future. So e to the something is always positive, never 0, never negative. Question. Awesome. That means this is always 1, so the value, the limit is 2. So this one has a different left half horizontal asymptote than it does on the right. Questions? Please.
On the test, can we write like the LA should be up or not left?
On the test, they'll just expect you to identify that there are 2 asymptotes. I've never seen them care, like, knowing that, hey, the blue asymptote is actually on the left half of the plane, the green asymptote is on the right half. They just care that you list both of them. I do that just for clarity that we're talking about 2 sides of the graph. So 2 points. Please.
How do you know if it's the left hand or right hand?
So I know it's the right hand, 2 for get in, because I'm talking about what happens as x approaches positive infinity. So I'm thinking of my graph and saying, oh, the x's I'm worried about are over here on the right half. So I'm figuring out that as x becomes very, very positive, the y-coordinate gets very close to 3. That's a asymptote on the right. 2 more. There you go. Solid. Let's